do the odd number problems from tonight's homework. I'll leave it to you to do the even number problems and fill in the puzzle part for the homework tonight. Again, this part here, we're going to try to isolate the absolute value sign to solve for this. So the first step would be to subtract 4 from both sides. So I have the square root of x over 5 equals 10. And now I have a square root by itself, which is exactly what I want. And now I'm going to square both sides. So I square this side and square this side. Raise to the second power of squaring, of course. So the square of the square root just cancels the square root part. So basically, the square root and this 2 cancel out, and I'm left with x over 5 equals 100. And now I multiply both sides times 5 to get rid of that 5 on the bottom. And these cancel, 5's cancel, and I got x equals 500. So this first one will be 500. When I check the work, 500 divided by 5 plus 4 equals 14. 500 divided by 5 is 100. Square root of 100 plus 4 equals 14. 10 plus 4 equals 14. That checks. So there's my answer. X is 500. All right, next problem is number 3 that we're working with. This is going to be the same thing I'm going to have here. I got the square root by itself already. So I'm going to square both sides. Remember, I'm squaring the fraction. The square root of a square disappears, the square root, so I got 8y equals. Now this is 1/2 times 1/2, which is 1/4. A lot of people put 1, but that's not 1/2 times 1/2. It's 1/2 times 1/2 is 1/4. And now I have to get rid of this 8. So I'm going to divide by 8, which is the same as multiplying by 1 over 8. But I'll write it this way, either way. Divide by 8, which is 1/4 times 1 over 8, which is 1 over 32. So that's the answer to this one. That's a y equals that. If I want to check, the square root of 8 times 1 over 32 equals 1/2, which means the square root of 1/4 equals 1/2, which is correct. So there's my answer, 1 over 32 for number 3. Now I got a little challenge with number 5 because it's a word problem. But I'm going to rewrite this as square root of 1/4 of a number. The square root of 1/4 of means times n is 6. So I get rid of the square root sign by squaring both sides. So if I square this, I must square this over here. So the square root of a square gets rid of itself, so these guys disappear. And I got 1/4 times n equals 36. So the next step would be to get rid of the 1/4, so multiply times 4. Multiply 36 times 4, and these cancel, and I have n equals 144. And I should check that. The square root of 1/4 times 144 equals 6, question mark. 144 times a fourth is 36. So that's the answer. Square root of 36 is 6. 6 equals 6. That's perfect. So that's correct. So 144 for number 5. Number 7 looks more difficult than it is. It looks like it's hard because I have 2 square roots, but the fact is there's only square roots on either side. So when I square both sides of the equation, what works nicely is the square roots disappear here, and they also disappear here. So basically what I'm left with is 7d minus 9 equals 2d plus 21. So now when I get everything on one, all the d's on one side of the equation, so I'm going to subtract 2d from both sides. These are canceled, and I have 5d minus 9 equals 21. And I'm not finished yet, but I've turned it into a pretty simple 8th grade problem. Now I'm going to add 9 to both sides. So that gives me 5 times d equals 30. And now I divide both sides by 5. These are going to cancel. D equals 6. Again, I should always check my work. So I'm going to look at this as being the square root of 7 times 6 minus 9 equals the square root of 2 times 6 plus 21. So that's the square root of 42 minus 9, which is the square root of 42 minus 9 is 33, equals the square root of 12 plus 21, which is the square root of 33. Square root of 33 equals square root of 3. That's good. So 6 is my answer to number 7. All right, the problems are going to start getting a little harder here because now we have variables outside of a square root sign. So before we square both sides, I want to get the radical symbol by itself. So I'm going to subtract w from both, add w to both sides. These are going to cancel, so I'm going to have the square root of 3w minus 10 equals w. And now I want to get rid of the square root sign by squaring it. So I square this side and I square this side. That's 3w minus 10 equals w squared. So now I have a quadratic equation which I need to solve. And to solve a quadratic equation, we want to set one side equal to 0. So to do that, I'm going to look at this one. I'm going to say minus 3w from both sides. And that leaves me with, these cancel, minus 10 equals w squared minus 3w. I'm going to add 10 to both sides. So I get 0 equals w squared minus 3w plus 10, because you can't combine those together. So now to simplify this, we got to work on our factoring here. W and w gives me w squared plus 10. They got to multiply to 10 and add to 3. That's going to be 5 and 2. And they both have to be the same sign. Oh, wait a minute. What happened here? Okay, I realized that I copied this problem down incorrect. So this should have been a plus. I apologize for this mistake here. That should have been a plus. Make that in black. That's a plus. Which makes this a plus here. I had a feeling this didn't look like it worked. So those are pluses, and now we're back to where we need to be. This is going to be a plus here, which makes this, let me change this back to, this is a minus 10. Okay, that's going to be minus and minus. I figured that wouldn't work there, so because the factoring doesn't work, but now it does when I fix this. That's a minus 10. So there, this would be, you have to multiply to 10 and subtract to 3, and that gives me 5 and 2. I just copied that down wrong. I apologize for that. So that's going to be a minus 5 and a plus 2. So when I don't need too many 2's there. So to solve this now, I'm going to say w minus 5 equals 0, in which case w equals 5, and w plus 2 equals 0, in which case w equals negative 2. So there's two solutions, but I need to check my answers because sometimes and very often one of them doesn't work. So let's go back to the original equation. We always do that from the original equation. So the square root of 3 times, we're going to check in this first case, we're going to check 5. We're going to check to see if 5 works. So 3 times 5 plus 10 minus 5 equals 0. I changed the w's to 5, and that gives me square root of 15 plus 5, plus 10, sorry, minus 5 equals 0. The square root of 25 minus 5 equals 0. 5 minus 5 equals 0. That checks. So one of my solutions is 5. So 5 is one solution. I'm going to check the other solution, which would have been -2. That's going to be square root of 3 times -2 plus 10 minus -2 equals 0. So that becomes the square root of -6 plus 10 plus 2 equals 0, because minus and negative is plus. So that becomes square root of 4 plus 2 equals 0. 2 plus 2 equals 0. No, it doesn't. That's not a solution. So there is only one solution to this problem, 5. All right, let's move on. Number 11. Again, we have a square root, but we have a variable on the other side of the equation, so I'm going to square both sides. So let me do this here. Square root of x minus 3 equals x minus 3. Now I square both sides, square this side. When I square the second side, I'm going to have to do my binomial multiplication, FOIL, sometimes we learn it as whatever. So this becomes x minus 3. And this side we have to FOIL. It's x minus 3 times x minus 3. That's going to be x squared minus 6x plus 9. Some of us can do it quicker than others. If I were to do that, that's x squared minus 3x minus another 3x plus 9. So that's what we get here. So now I have a quadratic equation. I want to get this equal to 0, so I'm going to subtract x from both sides. -3 equals x squared minus 7x plus 9, and now I'm going to add 3 to both sides. 0 equals x squared minus 7x plus 12. Now in simplifying that problem, I'm going to say 0 equals, and I put in factor that, I put x and x to get x squared. Looking for numbers that multiply to 12 and add to 7. That's going to be 4 and 3. And they're both the same sign, both negatives, both minus. So I have x minus 4 could be 0, or x minus 3 could be 0. So x equals 4 and x equals 3 are my two possible solutions. I again need to check both of them. So let's go up here and check them. We're first going to check 4 and see if 4 works. That's the square root of 4 minus 3 equals 4 minus 3. I should change these colors here. That's the 4. I'm changing this first x to a 4 and the second x to a 4. That's not a very good 4. A 4, and then finish the problem, 4 minus 3. So this becomes the square root of 1 equals 1, and that's true. So that means 4 is one solution. Now I'm going to check 3, and that's going to be the square root of 3 minus 3 equals 3 minus 3. All I'm doing is, to check them, I'm just writing the same equation here, just changing the x. Both x's to 4 gave me this answer. Changing both to 3, I get the square root of 0 equals 0, which is also true. So there are two solutions to this one, 4 and 3. All right, number 13 looks a bit confusing. First thing we have to do is get the absolute value by itself. So I'm going to subtract 5 from both sides. So I have y minus 5 equals the square root of 3y minus 5. And now when I have a square root, I want to get rid of the square root symbol. To do that, we square both sides. So I'm going to square this side. And remember, when we're squaring the whole thing. So that's going to be y squared minus 10y plus 25. Because over here, if I wanted to do that, I would say y minus 5 times y minus 5. Y squared minus 5y squared minus another 5y plus 25. And these two combine to be minus 10y. Equals 3y minus 5. And now I got to bring these two guys to the other side of the equation. So I'm going to subtract 3y. I'm going to that gives me minus 3y over here. That gives me y squared minus 13y plus 25 equals negative 5. The next step would be to add 5 to both sides. So I have y squared minus 12y plus 30 equals 0. And now I've successfully worked my quadratic equation so it equals 0, which means now I can factor this. And I have y and y. Two numbers are multiply to 30 and add to, that's supposed to be 13. Add to 13, that's going to be negative 3 and negative 10, because they're both negative, and that's what I get. So now, to solve that, I'm going to write y minus 3 equals 0. So y equals 3. Y minus 10 equals 0. Y equals 10. So those are my two possibilities. And I need to check 3 and 10 into my answer. So first I'm going to check 3. So that becomes 3 equals 5 plus square root of 3 times 3 minus 5. So basically what I've done is I've replaced this y and this y both times with 3. That becomes 3 equals 5 plus the square root of 9 minus 5. 3 equals 5 plus the square root of 4. 3 equals 5 plus 2. That's not true. So that means 3 is not a solution. So we go down here and we cross off 3. That's not a solution to this problem. Now I'm going to check to see if 10 works. Excuse me. So that's going to be 10 equals 5 plus, I change this, I'm going to go over here. Oh, let me go back a bit. Equals 5 plus the square root of 3 times 10 minus 5. So I have 10 equals 5 plus the square root of 30 minus 5. 10 equals 5 plus the square root of 25. 10 equals 5 plus 5, and that's true. So 10 is my only solution to that number 13. And now number 15 is a little tricky one here. 3 times the square root of a number is the same as 4 less than the number. So we're going to write that as 3 times the square root of n equals the same as 4 less than a number is n minus 4. Now this is one of the times when we probably don't want to isolate the radical because that's going to mess us up over here. I could do that. If I did this, I would say divide by 3, and I divide each of these by 3, and it's going to be kind of a mess when I do my distributing and FOIL. So I'm going to suggest that we know our math skills. We can go back and just, let's go back and leave the 3 on the other side. But we have to be careful when we do that, because when we square both sides here, we're going to square this entire thing here. That's where it gets confusing. And we're going to square the entire thing here. So this would become 9n, because 3 times 3 is 9, square root of n times square root of n is n, equals, and now when I square this, I do it the same way I always did, 9 minus 4 times 9 minus 4, n minus 4, and that becomes n squared minus, this is going to be n squared, minus 4n minus another 4n plus 16. N squared minus 4n minus another 4n plus 16. So that becomes n squared minus 8n plus 16. And now to solve this, I want to get rid of this 9n, make it equal 0. So I'm going to subtract 9n from both sides. That's 9. That becomes 0 equals n squared minus 17n plus 16. To solve that, I'm going to factor this. I'm looking for numbers that multiply to 16 and add to 17. That's 16 plus 1. And they're both the same sign. I don't want to put plus here, sorry. Because they're both to be the same sign, to get a positive 16, I'm going to have negative 16 times negative 1. And so n minus 16 equals 0, n equals 16. That's 16, not 12. N minus 1 equals 0, n equals 1. And we got to, again, put the numbers back into the original equation to see if they work. So when I put it in the first one, I'm going to, first thing I'm going to do is I'm going to check 16. And that's going to give me 3 times the square root of 16 equals 16 minus 4. So 3 times 4 equals 16 minus 4. 3 times 4 is 12. 16 minus 4 is also 12. That checks. So 16 is a solution. When I check 1, I'm going to get 3 times the square root of 1 equals 1 minus 4. That's 3 times 1 equals negative 3. Negative 3 equals negative 3. It does not. So this is not a solution, and nor is 1. So 16 is the only solution to that one.